Hi everybody, welcome to lecture 27 of Programming Fundamentals 1. In the previous lecture, we completed the module 5, which was the software engineering module, and we went over exception handling, how to do unit tests, how to use assert statements, as well as how to debug your code in IntelliJ. In this module, we'll be talking about how to design your classes, and we'll cover different aspects of object-oriented programming, which is a different philosophy of how we actually look at the code as well as at our data. So let's get started. Classes are central to this idea of object-oriented programming. But what is object-oriented programming in the first place? So far we have studied various computing constructs that include iteration, such as your for and while loop. We have went over if statements, which is also called sequencing. We also talked about different ways to manage the control flow of your program. All these constructs are available in almost every programming language, and one way where we saw one of the principles of object-oriented programming, or a general principle of abstraction, was the use of methods. So in the previous few weeks where we studied how we actually build methods, that's one way to abstract uh, a functionality of a computer program. Another way, or another philosophy of programming is called object-oriented programming. That philosophy where methods or these functions are central was called procedural programming, but now we are going to talk about object-oriented programming, which is basically a new way to look at the data as well as the functionality that can be offered on that data. Within these object-oriented programming paradigm, there are different constructs. Two central constructs that are central to this idea of object-oriented programming is classes as well as objects. And we are going to discuss those in today's presentation. So let's get started with classes first. So what exactly is a class in the first place? We have had this discussion earlier in the context of objects, which is when we were going over arrays as well as strings. We described what objects were, which is basically they were a type of reference-based data type, and objects are nothing but just an instantiation of a class. And what I mean by that, you'll understand very soon. So when we are talking about classes are basically blueprints that are used to represent a particular concept in the real world. So in our case, like let's take one example, which could be cars. A car is like whenever you are trying to build a software for a car, you could represent the car as a class, while an object is an actual implementation of that class, or a class in action, whereby the object could be an exact car that is available in the real world. So while classes may represent a generic car or the idea of what a car is, object is an actual car, which is let's say if you have your own car, which could be an Honda CR-V or a BMW Z3 or whatever, an object actually represents that class in action. And when we are talking about objects, or when we design classes, the classes basically have two different components in the object-oriented paradigm, which is the first one is called attributes, which basically defines what are the variables that are associated with a particular class. In case of a car class, think of what might be the attributes. One example for a car class could be the make, which is who is the manufacturer of this car, as well as there could be another attribute, which could be what is the year of this car. That's another attribute. Let's say if we are designing a software for a e-learning management system, we can think of one of the classes for that particular system would be a student class. And in that case, the attribute for a student class would be something like the name of the student, or what is the date of birth of their student, or what is the UFID of that student. And the second concept when we talk about classes is the concept of methods or functions which are supported by that class. And these methods basically allow some behavior to act on that object, or to manipulate the data. We need some sort of methods to actually act on that object. So an example of method for the car class could be maybe just getting the fuel capacity of that car, or what is the current fuel capacity that or the current fuel storage that the car possesses. For the student class, an example of method could be uh, what is the student's current enrollment, or let's say if we want to act on the student class by adding that student to a particular course, there could be a method to add the student which could accept the student as one of the parameters in that function and add it to a particular course. So let's see an example in this slide. We basically have an example of a monster class which is defined as whenever we are trying to define a particular class, we use the keyword public class followed with the keyword class followed with the class name. And by convention, the class name should always start with a capital letter. Another thing to note is whenever you have a Java file, you can just have at most one public class, which is you cannot have more than one public class in a particular Java file, and you have to save the Java file with the exact same name as the name of the public class, which is in this case, this file is called monster.java. Once you create this monster.java file in your IntelliJ, you can add this statement which is public class monster, because the name of the file should match exactly as the monster. Next, we are going to define some attributes of this class monster. So can anybody visualize like what could be the attribute of the monster? In this case, we have two different attributes which are also called variables, or in core terminology, these are called class variables or instance variables in the terminology of object-oriented programming. We have two different variables right now, which is one is int level, which is what is the level of this monster, and the second one is the string name, which is this monster might have some name. What we mean by public and private you will know in the next slide, but these are basically access modifiers and they provide some kind of restrictions on how we can use these variables. We are going to discuss that in the next slide, but you can think of it right now as this class monster has two different variables. The first one is int level and the second one is string name, and these variables are called instance variables or class variables because they are defined not within a method but within the class, and their scope is limited to the entire class, which is these two parentheses. Next, we are going to define a method, and in this case we have a method called public void set level. And what this method is doing is it's taking a new level and it's setting the new level to the level of this particular class. So right now the level is 0, but we can, if we call set level on the object of this particular class, you can actually set a new level uh, to the existing level by calling this particular method. Another thing to note here is that this public void set level is different from the previous methods that you have built. Remember earlier you had the static keyword, but this method does not have a static keyword, which is this just has public void set level. And what this means is that you cannot change the level of a particular monster by calling something like monster.setLevel. You actually need an object of this class, and how we build objects you're going to see very soon, but you need an object to actually change the set level, which means you cannot change the level of a particular monster uh, by just calling the set level on the monster class, which is you cannot do something like monster.setLevel. You have to create an object of this class. We are going to very soon discuss how to create objects, but you have to use an object of this class to call like object.setLevel. It's pretty similar like when we earlier saw about strings. And we saw that we talked about instance methods as well as static methods. This is an example of instance method where you have to call this method by using an object. I also wanted to let you know that by the general rule of thumb or by general convention, since this class actually defines a template, it's not a good practice to actually initialize your variables within the class. By default, these variables should actually be initialized to nothing, and they should be initialized when we talk about something called constructors. You are going to understand that you need to initialize these values by following the initialization process in something called a constructor, which we are going to discuss very soon. But before that, we'll just see in this slide how to actually define or create an object of this type monster, which is how to bring this monster entity or operationalize this monster entity into something which is more concrete. And we do that by defining a new file which is called myprogram.java. Again, we have the simple public class myprogram, and in this myprogram we are going to define a new void main method in which we are going to create an object of this type monster. The common convention to actually create this object of a particular class is you use the class name followed with an object name, which is in this case we have class name and followed with an object name. So this particular left side actually creates a reference variable that can store an object of type monster, which is earlier when we talked about arrays as well as strings. Since both arrays and strings were objects, we knew that this left side, if we just ended the statement right after this with a semicolon, just creates a reference variable that stores object type reference of type monster. So in this case, the left side is actually stored in the stack. So in this case, we have this pika variable that's stored in the stack memory and not in the heap memory. And when we talked about earlier, when we talked about the new keyword, we discussed that this new keyword always allocates memory on the heap, which is the strings implicitly call this new keyword. When we were using arrays, we were explicitly using the new, like let's say if we are creating an int array, so we use this convention that we called int arr is equal to new int maybe like 10. So what this new keyword did was it allocated 10 spaces of memory when we are defining a new array. But in this case, it's defining with the new keyword, we are calling a monster type constructor. We are going to discuss constructors very soon, but we are creating a monster type object. So what this entire statement will do, the right hand side will create a new object in the memory, in the heap specifically, or it will allocate size for a new monster object and return the address of that monster object in the heap to this pika. So pika will now start pointing to this monster object. So in this case, now pika is pointing to a new monster object, and what this monster object has, it has two different, like each of the monster objects which we are going to create by this new monster statement will have a level as well as name, or all of the instance variables of that particular class are stored in the heap memory. So let's say if somebody asks you in an interview or something, what is the size of the pika object, you can actually calculate the size very easily, because we talked about the different primitive data types have a particular size. So in this case, the integers might be 8 bytes or 16 bytes based on different compilers. So each of the object of type monster will have 8 bytes for the level, and for the name, since for strings, one particular character might be stored in a byte. So in this case, since we have the string is very dynamic, so in this case it could have it depends on the size of the string. But let's say if it was an integer and a double, another variable was of type double, then you can very easily answer this question that the size of the monster variable, which is a monster reference type variable, would be actually equal to the sum of each of the instance variables. Another thing to note here is we have named this monster Pika, but you can name it using any particular identifiers that we earlier discussed. The correct naming convention that's usually followed is which is encouraged is you follow the camel case, which is you start with the small letter and then you have every other word might be a capital letter. Now you can change the values of this monster object that you just created. You can access the instance variables by using this dot operator. So in this case, if I want to change the name of this monster from some monster to choo choo, I can just use pika.name and set it to choo choo. So this will change the name to choo choo. Also, you like in the next slide we are going to talk about access modifiers, but you might have already guessed that we can use only this convention for public instance variables. So in this case, since it was public, we could use something like pika.name, but if we try to do something that like pika.level, this will give us an error. So how to actually set private variables, which is like these kind of variables are not accessible from outside the class. Like since we are accessing this monster class from outside the class, we can use the public method to set the level. So in this case, we can do something like pika dot set level, and this will and pass in the level 10. So this will actually change the level of pika to 10. So you can see that pika is pointing to name in this statement, which is choo choo after this line, and after the set level line, this level is actually changed to 10. Once again, let's see the quick execution of this program where we create two different programs in two different files. The first one is monster.java. That's basically a template for our monster class. And the second one is myprogram.java that has the main method that actually creates the object of this class and he handles the execution. So initially when we have this class, we have on our stack this main method which has the arguments variable. Next, after this statement, we'll have another a reference variable of type monster that will actually store or point to a location in the heap memory that stores a monster object. So in this case, the monster will have the level 0 as well as the name some monster based on our initialized values. Next, we change the name of this variable to choo choo. So in this case, it starts pointing to choo choo, followed with our new method call, or we are calling the set level by using the object, or how we actually call the a particular method of a class, which is non-static in nature by using this convention object dot method name. So in this case, we are doing pika.setLevel. So what it does is it passes the 10 to the new level, and we have a new stack frame now because we are calling this method, the setLevel method, which has a value of 10 that's being passed into the new level. This changes the actual location or the value of the object in the heap to the new level that we have passed in. So in this case, the level 0 will change to level 10 in this case. This, after that, there are no lines in our particular void main. So basically, we return back from the set level first, and this stack frame is deleted, followed with the deletion of the main stack frame, and then the garbage collector, which is a kind of a tool within the Java compiler that deletes all the memory. So all of the memory is now deleted in the heap. So let's see a quick demo of the two classes, the monster as well as the main program we discussed in IntelliJ. And how you're going to do it is like whatever folder you are working on in IntelliJ, just add a new class. And I'm going to name this as monster.java. Now this class is named like once you define this new class, IntelliJ has already done the work for you, and it has defined this class as public class monster. This class I'm going to zoom in a bit so that it's more clear to everybody. Now I'm going to add two different instance variables or class variables to this public class monster. The first one is called string name, and I'm going to name this as some monster. The second instance variable or the class variable we have is int level, which is initialized to 0 in our program. We can define these as both of these as public or private or whatever. We are going to define what these terms mean in the next slide, but I just wanted to give you a demo before we get started. So now this class has two different public variables, which are string name as well as int level. You can also define different methods, which could be, let's say I'm defining a new method which is public void name uppercase. So what this method does is it changes the string name of the current object or current monster to name dot uppercase. So I'm going to use the name dot uppercase method to change the string's name to uppercase. Next, what I'm going to do is I'm going to save this file and create a new class to create an object of this particular file. So in this case, I'm defining this class as lecture27.java. Next, I'm going to create an object of this class, of our monster class in this class, and I'm going to create a main method in this class. Now I'm going to create an object monster, which is, I will type the name, class name monster, followed with my object name. In this place, I'm just calling it obj. And how you actually define the value of an object is using the new keyword followed with the monster or the class name and a set of parentheses. This will actually create a new object in our memory, which is named obj. So let's say if I want to print this object, since we initially defined the value of this object to some monster and level, I can just print this, the name of this monster using obj dot name, because initially, like you can see, the name and level are of type public, so I can access these particular values using the object.name. And once I'm going to run this, you can see that our program prints the name of the object. So in this case, it would be some monster. It's not printing right now because I have to select or reconfigure my program to lecture 27. And now I'm going to run this. So you can see very clearly that it prints the sum monster. Let's say if I now call the method on this object, IntelliJ provides us the list of methods that can be applied to the object, as well as the different variable or class names that are associated with this object. So in this case, the monster class has two different instance variables, which is name and level, or two different attributes. It has one method which is called name uppercase. So I'm going to call that. So this method doesn't do anything, like it doesn't return any particular value, but it just changes the earlier name to name dot to uppercase. So now I'm going to print this system.out.println object.name, and we'll have two different names here. The first one will be some monster, and the next one would be capital Sum monster, which you're going to see right now. So you can see the name of that particular variable is changed. If we want to print out the level, it's pretty straightforward. I'm going to just copy this entire statement and just change obj.name to obj.level, and this prints the object.level. which is 0 in this case. Another thing I'm going to talk about right now is the introduction to access modifiers. So what access modifiers are they are basically 4 different types of access modifiers. We are going to see those in the next slide, but the most common ones are public as well as private. So let's say if I was to change this to private, what this means is you have some sort of security that's provided to each of the variables or to each of the methods that are defined within the class, or even the classes have different access modifiers. And what they basically mean is there's some sort of restrictions that are applied on that particular entity in object-oriented programming. So what this public one means is this is the most kind of liberal kind of access modifier, where which means that you can access this particular variable name or this particular method name from any of the classes that has created this object. So what I mean by that is, you see that we have 2 different files. One is lecture 27, another one is monster class, and we are creating this monster object in a different file. So public access modifier allows us to manipulate these variable names, which is in this case, you can access this particular name by using directly the object, which is you have access to object.name. But let's say if this was private, like in this case, I've made the second variable as private, which is level, you cannot access it using obj.level. And this is particularly very useful concept in a lot of security applications, and most of the times all of your variables, the class variables, are usually it's encouraged that they should be private. And there's something called getters and setters, or accessors and mutators, that we are going to discuss in the next slide, that are used to actually change the values or access this particular variable. So in this case, I cannot do something like obj.level, because once I try to run this, I'll get a compiler type errors that I'm trying to access the level which is of type private in the monster.java. So the private variables or private access modifier is kind of the most restricted modifier, and what it does is it only allows a particular variable or a method to be accessed within the class, which is you have free access to this level variable within this class. Like you can manipulate level here because it's in the class, but you can not do anything with these private variables outside the class. Like you cannot access it like this. So if you want to access level or change the level, you need to have a new method, which is I'm defining it now, of type public, and I'm naming this as set level, which changes the level of your particular class. So in this case, I'm changing it to L, and I'm passing a new variable named L in the set level. So if I want to change the level, I can change it using the set level function, or if I want to get the level, I can get it using this get level, which doesn't take any parameter, but it's of type integer, and it basically returns the level. So now if we go back, and instead of object.level, we can do something like object.getLevel, and now it should work fine. So pause this video and try to guess what should be the output of this object.getLevel here. So in this case, it should be, since we are not setting the level anywhere and we are just getting the level in the main class or in the main file, we just get like the value that's printed is 0. So we get some monster, another some monster, followed with a big 0 right after that. So let's go back and talk a little bit more about public, private, and the other type of access modifiers, and then we are going to go into accessors as well as mutators.